Hello. In this video, we are going to continue our work on Chapter 5 of the Stanley Baronet textbook on categorical logic. In this unit, we're going to begin discussing our last real significant topic within the branch of logic that we've been studying for the past week and a half, categorical logic. We're going to discuss two different topics as an introduction or on an introductory basis. First, immediate inferences, which we've already come to be a little bit familiar with on our square of opposition, but we're going to learn a few more moves that we can make with single sentences to test for validity. And then we're going to learn how to use Venn diagrams, which is a way of visually representing the types of categories on our square of opposition. So I'm going to go through each of these in turn. The first topic that is introduced in section C is a sort of an abstract idea, and it's been much discussed throughout the history of philosophy and the history of logic, and it's the question of existential import. Existential import really is a question regarding whether or not the class terms in our categories do exist or not. That is, whether or not they actually refer to real entities in the world. And logicians have kind of argued with themselves over whether or not you can have valid arguments with class terms that do not necessarily exist in the real world. So the term existential import refers to a proposition that presupposes the existence of certain kinds of objects. Okay, so to have existential import is to exist, or to in a sense, presuppose the status of its existence. So let's compare two sentences. If we compare all cats are mammals, this is, as you probably can recognize by now, a universal affirmative proposition, right? This is our A category. And we could say that this is true in a sense because cats really do have existential import. But if we could contrast that sentence to this sentence, a sentence like this, all unicorns are mammals. Again, it's the same category type. It's an A proposition, a universal affirmative. But now we're talking about unicorns. So the thought might be that this is false because the class term in the subject group does not exist in the strict, literal, empirical sense. So this kind of, might confound us a little bit. Can we speak of valid arguments with class terms that don't necessarily exist in the real world? Well, for some logicians, yes, that's fine because we're only looking at the structure. But for others, no, the existential import is a factor. Okay, so to simplify things a little bit here, we've kind of divided up logic into two broad interpretations that have different approaches to the question of existential import. The first is referred to as the Aristotelian or traditional interpretation of logic, coming out of Aristotle's systematic logic. In Aristotle, we have a particular approach to the question, and then we counterpose the Aristotelian or traditional approach to what is known as the modern interpretation. Okay, and there are some significant differences between these two branches of categorical logic. Okay, in the Aristotelian or traditional interpretation, it is required that we determine whether or not the class terms for universal categories exist or not. All right, so in a sense, existential import is an issue for subscribers to the Aristotelian or traditional interpretation of logic. All right. The modern interpretation, on the other hand, suspends some judgment about the existence of universals. All right, it is not interested in that question of the factual empirical existence of the class term for the universal category terms. Okay, so that's a very big difference in approaches, and you might wonder, well, what justifies the modern interpretation to suspend judgment about the existence of universals? All right, and we'll see different ways in which this yields very different inferences at the level of how much we're allowed to infer about certain categories. Okay, we're going to return to that issue of existential import as we look at Venn diagrams in particular. But now I just want to walk you through a little bit, a couple of nifty moves that we have for immediate inferences. And remember, An immediate inference is an inference about or that moves from a single sentence from our four standard types of categories. Okay, and what these allow us to do is essentially manipulate the single sentence into what is known as a logically equivalent proposition. So to have a logically equivalent proposition means that the arrangement and perhaps even the relation of terms looks different than the initiating sentence, but really the logical sense is exactly the same as the first sentence. Okay, so we're going to walk through a few different immediate inference transformations that will allow us to, in a sense, play with the categories in some new ways. The first type of immediate inference is known as conversion. I think conversion is probably the simplest and most straightforward of the immediate inferences. It's really just one transformation to the sentence. So just to define it, if I can get out of the way here, a manipulation of a categorical proposition that entails the switching of the subject class and the predicate class. So all you have to do to convert a categorical proposition is switch the subject term with the predicate term. Nothing else is changed in that sentence. So for all E and I propositions, the converse of that initiating sentence is said to be valid. We can validly infer for I and I propositions that the converse are valid inferences. Okay, so we'll have to talk about the A and the O propositions on the square, but we know that for any E and I, you can validly convert the terms. So let's just kind of spell this out a little bit. If I have an E proposition, which takes the form no S R P, the converse of this E proposition, no matter what the content, would simply be this: no P R S. You simply switch S and P to generate the converse, and that is true for the I proposition, which would begin some SRP, and that becomes some PRS. So for whatever the content in the world, you can validly infer the converse for E and I propositions. If our content becomes no S, where S is cars, and the predicate is boats, if it's true that no cars are boats, we can infer that no boats are cars. Okay, so this probably just kind of makes some common sense to you, but it's helpful to have this as an actual law, as it were, of transformation. Okay, so that is conversion. Now, conversion for A propositions gets a little bit trickier, and remember that the A proposition occurs on our circle, on our square of opposition as the upper left hand corner of the square of opposition, right? It's our universal affirmative, and we know that it corresponds to the particular affirmative, some SRP at the lower left. And there's something that we have to do here in order to convert A propositions. We can't immediately convert any A proposition by simply switching S and P. We have to undergo kind of an intermediate step known as limitation. And what that means is we simply transform the A proposition into an I proposition. And then once we have brought it down on the square, then we can apply conversion. So all SRP becomes some SRP, and then the converse of the I term becomes some PRS. Okay, so we infer the corresponding I proposition through subalternation, right? Remember, our rule allows us to find the subaltern by bringing A down to I, bringing the universal down to the I, and that leaves us with essentially a sentence that is smaller in scope. It is a particular rather than a universal from which we can then apply conversion. Then we can switch the S and the P for the I proposition. Okay. Conversion, however, is never valid for any O proposition. It is never valid for our particular negative propositions. Okay? So for any E and I proposition, we can immediately find the converse. We can immediately switch S and P. For the A propositions, for the universal affirmative, it is only valid through limitation. You have to transform the universal into a particular and then apply conversion. So it's just one extra step, but still finding the converse for an A proposition is pretty straightforward. All right. We now move on to our second type of immediate inference, and this is known as obversion. Obversion is a little bit trickier than conversion, and it might become a little bit tricky because these immediate inference types start to seem very similar to one another, but they actually mean things that are very different, and the moves you have to make are quite a bit different, even if they seem subtle. The good news about obversion is that they're valid for all four types of a categorical proposition. They work immediately for A, E, I, and O on both interpretations of categorical logic. So you don't have to worry about limitation for obversion. It works for all four. It's a very flexible kind of inference. And what is the transformation? Well, to find the obverse for any categorical proposition, the first thing you have to do is change the quality. So remember what quality means. Quality refers to affirmation or negation. So if you have a sentence that is affirmative, to find the obverse means that affirmative is going to have to become the negative. And if you're beginning with a negative category, the negative is going to have to become affirmative. Think of it as flicking on a light switch. These terms are all binary. Quality is binary, quantity is binary. And so the good news is there's only two options, right? The next move is to add the complement to the predicate term. The complement, I think, trips up students a little bit because it becomes very clunky in English. What the complement means is essentially the negation of the predicate term. Non is going to be our key category, our keyword for the predicate. So the complement essentially refers to every term in the universe that is not a member of that predicate group. All right, so to add a non before the predicate is to add the complement. All right, so if we begin with this sentence, all S are P, ask yourself first, what type of category is this? This is an A, right? This is our universal affirmative. So the first step is to change the quality. Because it's affirmative, it has to become negative. So you'll notice we have negation in the obverse. And then we added the complement to the predicate right here, non-P. So the obverse of any A is no S, R non-P for any content in the world. So if I were to give a concrete example, if we have an A sentence like this, all teachers, where teachers are our S class, our teachers, all teachers are geeky persons. Excuse my handwriting. Okay, begin with this A sentence and try to find the obverse for yourself. Remember, you have to change the quality first, and then you have to add the complement to the predicate term. Try to write that down for yourself. Okay, so changing the quality brings us to our E category, right? It has to become universal negative, so we got no teachers. Nothing transforms about the subject term beyond this, right? We're retaining the exact same subject class. Ooh, this is getting sloppy. No teachers. And I want to really stress about how to do the copula here, because this gets tricky with obverse, because our brain starts to not like these complement terms. Really, we don't like negation very much in English. It's just kind of clunky and often very ungrammatical. We're actually not going to concern ourselves with grammar terribly much here in categorical logic, right? Sometimes we have to be ungrammatical to express the correct logical sense of these terms. Now, we are going to be holding on to the exact same copula, are. It's just we are now going to add our complement to the predicate class, are non-geeky persons, right? If I can write geeky. Okay. So be careful here. Don't write not, are not. That is a very different sentence than no teachers are non-geeky persons. This is the converse of all teachers are geeky persons. All right, so we needed that non-dash predicate term to have the complement in place, not are not. That is a different sentence. Okay. If we look at another variety here, let me just get out of the way. If we begin some S are P, the converse becomes all S are non-P. I like to think of the obverse as just kind of taking the initiating sentence and twisting it inside out, as it were, right? We're flipping quality and adding complement. But notice these terms are totally logically equivalent. They're really logically telling us by different means the exact same thing. Okay, so that's what we're doing with these immediate inferences. These are logically equivalent. And then we have some SRP. Ask yourself, what kind of sentence is this? This is our I, right? Oops, that's sort of hard to see. And then the I term becomes some S are not, right? We needed to change our quality to negative. And then we added our complement with non to P. So this becomes tricky. Students tend to not want to have both are not and non. But we do need for an I proposition both the not and the non, because to change the quality from the I term, this has to become an O term, right? This has to become an O proposition and has to become our particular negative, right? So in order to retain the quality, particular negative, and add the complement, we then also need that non term. So even though it sounds very clunky to have both not and non, that is accurate for the obverse. So do be careful when you're trying to provide the obverse for an O term, or rather for an I, which becomes an O. Okay? If we look at this one, some S are not P. The obverse of some S are not P becomes some S are non-P. So again, ask yourself, the initiating sentence, what kind of proposition is it? This is an O proposition, right? This is a particular negative. Some S are not P. To find the obverse, we switch the quality. The negative becomes affirmative. Some S are. And then we add the complement to non-P. These are logically equivalent. All right, some S are not P is logically equivalent to some S are non-P. All right, so it'll take some time for you to get used to having a feel for this and learning how to apply those complements in a way that retains the transformation of the quality. When do we use not? When do we not use not? That doesn't make all that much intuitive sense. It just takes some practice. Okay, but you will get there. Okay, let's move along here. The last immediate inference type I want to explore with you is called contraposition. Contraposition entails the most transformations, but it's in a way simpler, I think, than obversion in my view. Um, Contraposition is valid for A and O propositions. It is valid for universal affirmative and particular negative. To find the contrapositive for an immediate inference, we switch S and P. All right, so it begins just the same as conversion did. We're switching the subject and the predicate terms. And then we're going to add the complement to both S and P. All right, so we're not just adding the complement to P, but we're adding the complement to both S and P. And this can be a stumbling block because it looks really awkward and can often be a mouthful. Those finally transformed contraposed sentences having two complements in them, not at all grammatical English, but logically quite valid. All right. If we look at the exceptions to our contraposition, can I validly contrapose E propositions? The only way you can do the E proposition is by limitation. Okay, so remember, with conversion, we were able to convert A propositions by limiting the A proposition through subalternation. We turned the A proposition into an I proposition and then applied the rule for conversion. The same story goes here with E. So you can't immediately, on the square of opposition, counterpose an E proposition. Remember, what is our E proposition? It's our universal negative. So if we start over here with any E prop, the corresponding category is our O, right? Through subalternation, we can transform E to O, becomes particular negative. Then once we've made that move, we can apply the moves for contraposition. We switch subject and predicate of the O proposition and add the complements to the O proposition as well. So it requires that extra intermediary step. Infer the corresponding O proposition through subalternation and apply contraposition. Let me clean this up here. Switch S and P and add complements for both S and P. Okay, so we can't immediately do contraposition for E, but you can through limitation. I propositions can never be contraposed. Contraposition is never valid for our particular our particular affirmative proposition. So the I propositions are totally excluded as valid immediate inferences for contraposition. Okay, so we got to remember our exceptions, right? We got to remember which ones are valid for which. I urge you to write this down on flashcards or at least in your notes and make careful note of which ones are never valid. All right. So here's some examples. If we begin with a sentence like this, all S are P. This is an A claim, right? To find the contrapositive, we are switching S and P. So notice we have flip-flopped. We've brought P over here. We've brought S over here. And then we've added non to both P and S. And this is a valid contraposition for whatever content we're dealing with. All right. We move along here. No SRP. This is an E proposition. No SRP. We flip-flop S and P. No non-P are non-S. Some SRP. Some non-P are non-S. Some S are not P. This is our O proposition. Some non-P are not non-S. That last contrapositive for an O proposition is going to become a mouthful because we need that are not non. We need to have both the negation for the O and the complement for the subject term. That's going to take a little bit of practice. So don't worry if it's uncomfortable as we're filling in the content. But do note that no matter what, with contrapositives, two nons are going to be occurring, right? The complements are going to be occurring for both the predicate term and the subject term. Okay, just to talk a little bit about some of the history here of categorical logic. A lot of this stuff is coming from a fellow named George Boole. George Boole was a 19th century mathematician and logician, and he is really responsible for mathematizing logic. He is really responsible for a good deal of the modern notation in the interpretation we're dealing with. This is known as Boolean logic. Boolean logic refers us back to the question of existential import with respect to universals. He is also a huge forerunner to the development of the modern computer and the logic behind computer circuitry. So if you think logic is just a completely abstract, speculative endeavor, you are mistaken. There is a direct pipeline from figures like Boole and Alan Turing to modern computing. It would really be inconceivable to imagine modern digital computing without the innovations of figures like Boole. We then have a figure named John Venn, and John Venn is responsible for our famous Venn diagram. He is similarly a 19th century and partially 20th century figure who designed the Venn diagram, which perhaps we're all familiar with. We're going to see how it works in logic. And he also is a key figure in the development of set theory. So there's a good deal during this period of intellectual history of overlap between mathematics, logic, metamath, and the foundations of essentially what became software. Okay, let's talk about the Venn diagram on the traditional interpretation of logic. We're going to end up applying this to our categories. We know what Venn diagrams are, essentially, right? It's just a figure that represents the relationship between certain categories. And so it sort of makes clear sense why it would be useful for us to use it in categorical logic, because all categorical logic is doing is exploring the relationships of class terms to one another. So what we're going to do here is use a Venn diagram, a two-part Venn diagram, to try to visualize essentially the relations of inference that we've been unpacking. So notice this Venn diagram has four regions. The first region is the subject term, right? We're indicating the subject term with S. So over here is going to be in region 1 our subject group. And then you'll notice region 2 is the region of overlap between the subject group and region 3, which is our predicate group. So over here we use P to indicate predicate, and everything in 3 is the predicate class. And then we have the region outside 1, 2, and 3, which is just indicated as region 4. Okay, so it's external to subject and predicate. Okay, so what can we do with this? We have a way of diagramming all four types on the modern interpretation of our categorical propositions. They give us kind of quick and nifty snapshots of the relationships of the four categories on the square of opposition. So if we look at our A proposition again, the universal affirmative, the Venn diagram for the A proposition looks something like this. All SRP. Okay, so what's going on here? We have, you'll notice, shading in region 1 of the Venn diagram. And what this indicates is that in that shaded 1 region, there is nothing out there. There is nothing that exists. Why? Because all subjects in this proposition are also members of the P class, right? All S are P. That is the meaning, the underlying logical meaning of the universal affirmative. So every S that is also included in this P group. So we have this region 2, which is the portion of the subject group that is excluded from 1, and region 3, which is the predicate group not shaded. So to indicate your universal affirmatives on the modern interpretation, we shade region 1, but we do nothing to regions 2 and 3. And this indicates total exclusion of anything that's an S that's not also a P, because we have no reference to any member of S that's not also a P in this sentence. Okay? For the E proposition, the universal negatives on the modern interpretation, no SRP, you will find shading in region 2. Why? Well, there's nothing in there. To say that no SRP means that no S that exists is also a P. And the second region is precisely where S is also P at the same time. And this proposition is saying that doesn't exist, right? So we are blocking in, we're shading region 2. For every S that exists, it's out here, and for every P that exists, it's out here in region 3. Okay, so, the E proposition includes shading in region 2. All right. Now we're moving on to our particulars. With the universals, you'll notice we use shading, but with particulars, we're going to use a little X to indicate the existence of one particular. All right, so for the particular affirmative propositions, the I category, some SRP, we are going to include an X in region 2. Why? Well, to say that some SRP means that there is at least one member of the subject class that is also a member of the predicate class. So it can't be in region 1, that would exclude it from the predicate class, and it can't be in region 3, that would exclude it from membership in the subject class. So the I category proposition is going to include just an X to indicate the membership of at least one S in the world that is also a member of the predicate term. Okay, so don't confuse I and E, where in the E proposition we have shading in region 2. That indicates non-existence in the area of overlap between subject and predicate. Here we have the existence of one member or more that coexists, as it were, between S and P. Last but not least, we have our particular negative, our O proposition. To indicate the O proposition, we need an X in region 1. Why? The O proposition means some S are not P, so we know there is at least one member of the subject group, and the O proposition, the negative, tells us that it is definitely not a member of the predicate group. So it can't go in region 2, where subject and predicate overlap, and it can't go in region 3, because that would indicate membership in the predicate group to the exclusion of the subject group. So the O proposition has to put an X in region 1. That is how we indicate our O propositions. An X indicating the existence of one particular in the subject class that is excluded from the predicate class. Okay? So I urge you to write down all 4 categories on the Venn diagram for our modern interpretation to become familiar with what these look like, because we're going to start using them. Okay, in the next video, we're going to have a look at how these things work a little bit more concretely, but do try to review the laws of conversion, obversion, contraposition, and the 4 placements of the Venn diagrams for our categories. And we will continue next time. Thank you.